Hello friends, welcome to my channel Master the Monster. Are you the one who think math is a monster? Are you frustrated with your heavy mathematical calculations? Are you haunted by the homeworks given by your math teacher? Are you annoyed about your mathematics exam? Now you can stop worrying. With little interest and regular practice, you can master the monster. All that you need to do is just subscribe to my channel so that you can join with me to overcome your fear for maths. Okay, class 10, Cbse Maths, Chapter 1, Real Numbers, Exercise 1.2, Problem number 1. Express each of the number as a product of its prime factors. So we are given 5 numbers. We are asked to express them as product of primes. Okay, it's a very simple problem. Let's start doing one by one. Okay. Okay, now let's start with 140. Alright. Let me divide this 140. So I have given the divisibility test link in the description box so that this prime factorization will be easy for you, right? Okay, now 140, this is divisible by 2. So let me divide it first by 2 so that I get the quotient to be 70. Alright, then again it's divisible by 2. So let me divide it by 2. I get the quotient to be 35. Now this number is divisible by 5. So I get 7 as the quotient. So now this 7 is a prime number. So I can't further divide it. So let me stop it here. Even if I divide, I'm going to get the product to be 7 and 1. So if you want, you can divide. Otherwise, you can stop with 7, whatever be. That's nothing wrong in it. Okay. So now I have written 140 as 2 into 2 into 5 into 7. Otherwise, I can say this to be 2 square into 5 into 7. Right? So I have expressed 140 as product of primes. Now let me try to express the second subdivision 156 as product of prime numbers. Now let me divide this 156 by 2 because it's divisible by 2. So I get the quotient to be 78. Now let me again divide it by 2 so that I get the quotient to be 39. Now this 39 is divisible by 3. So let me divide it by 3. I get the quotient to be 13. Now 13 is a prime number, so we can stop here so that I get the factors to be 2 into 2 into 3 into 13. Otherwise, I can write it as 2 square into 3 into 13. This is how I express 156 as product of primes, right? Okay, now let's go for the next subdivision 3825. Now let me divide this 3825. We very well see that it is divisible by 5. So let me divide it by 5 so that I get the quotient to be 765. This is again divisible by 5. So let me divide it again by 5 so that I get the quotient to be 153. Now this number 153 is divisible by 3. So I get the quotient to be 51. Again we see that this is divisible by 3. So I get the quotient to be 17. 17 is a prime number, so we'll stop here. So now I have got the product of primes is 3 into 3 into 5 into 5 into 17. I have just written in the ascending order, that's all. The order doesn't matter. So now I can also write it as 3 square into 5 square into 17, right? Okay. Now, the next subdivision is 5005. Let me divide 5005. 5005, we see that it's divisible by 5. So that I get 1001. Now I see that this is divisible by 11. So I get the value to be 91. Okay, now again this is divisible by 7. So I get the product as 13. Okay, now I have factored this 5005 as 5 into 7 into 11 into 13. None of the factors is repeated, so I need not express them as powers. I will simply leave it as it is, right? So this is the prime factorization of 5005. Okay, now let's factorize 7429. Applying the divisibility test, I found that this 7429 is divisible by 17. Right? So that when I divide by 7429 by 17, I get the quotient to be 437. And again, applying the divisibility test rules, I find that this 437 is divisible by 19 and the quotient here is 23. Right? So for this only I have made the video of divisibility test. If you have watched, it's okay. If you haven't watched, then the link is in the description box. You can make use of it so that the factorization will be as easy as that, right? Okay, now I have factored 7429 as 17 into 19 into 23. Here again the factors are not repeated, so let me leave it as it is. So this is how I factored all the 5 numbers as product of prime numbers, right?